Let's learn more about systems thinking. Tiny variations can affect the giant and complex systems. The prediction of behavior of any large system is virtually impossible without accounting for a multitude of tiny factors, any one of which might have a small but significant effect on the system. You may have heard of the butterfly effect. This is the idea that wing movements of a butterfly might have a significant repercussion on wind strength and conditions throughout the weather systems of the world, and theoretically could cause tornadoes halfway around the world. By understanding systems, their interactions, and their changes, we can establish and maintain a focus on processes and achieve organizational strategies. Dividing an elephant in half does not produce two small elephants. Failure to see the system as a whole can cause major mistakes. This flaw in perception and vision often leads to hasty decisions, extra work, and lost time and energy. Small changes can produce big results. The most grand and splashy solutions, like changing company policy, vision, branding, or tagline, seldom work for transforming change. Small, ordinary but consistent and repetitive changes can make a huge difference. Think about the difference between a family and four strangers, or a car and all its parts present but disassembled, the human body and all its organs separated. The difference is that a system is not the sum of its parts, it is the product of their interactions. This implies that the performance of the system depends on how well the parts fit together, not how well they perform individually. Thus, the best parts do not necessarily make the best whole. They have to fit together. For example, the best players or smartest people brought together to form a team. System thinkers are generalists, focusing on the whole system. They are non-linear thinkers, questioners who model and evaluate the relationships between parts and processes. As a system thinker, you will identify the circular nature of complex cause and effect relationships. You will check results and change actions if necessary. You must take into account both short and long-term consequences of actions. You do not jump to conclusions. You take time to consider an issue. You must recognize that a system structure generates its behavior. You observe how elements within a system change over time, generating patterns and trends. You seek to understand the big picture. Now that you are familiar with the basics of systems thinking, here's a quick video on how a systems thinker would handle the situation of a clucking hen that's waking the neighbors.
Systems thinking is a way of seeing, a method to help people appreciate complex problems. As an extension to scientific thinking, which solves problems by breaking them into ever smaller elements, systems thinking focuses on the relationship between these elements. For example, imagine I have a problem with my pet hen. It wakes the neighbours. The systems thinking approach is to better appreciate the problem by viewing the hen within a series of systems. One of these systems might be the hen's internal system, its stomach, guts, eyesight, etc. This internal system of the hen receives food, water, air, light, visual stimuli, etc., and changes them into feathers, meat, manure, eggs, danger alerts, and clucking. However, the hen can also be seen as one element in a farming system that produces eggs or meat. Or the hen can be seen as evidence in a legal system, or as part of the bird genus in an evolutionary system. To see a problem using systems thinking is to see it as one part of as many different systems as possible. By appreciating these systems, a solution to the problem might suggest itself. For example, change the hen's perception of time and it will be less inclined to cackle as a response to daylight hours. This shifting from system to system allows us to perceive the problem from a variety of perspectives.
Another example using systems thinking is through Dr. Seuss's story, The Lorax. If you haven't read The Lorax, it's basically about a businessman who is greedy. He cuts down the truffula trees in order to make thneeds to make more money. As he sells more thneeds, he makes more money, and his factory grows, which means he cuts down more trees, which leads to pollution, hurting the environment, and the animals eventually leave. After reading The Lorax, students developed a connection circle and causal loops to understand the themes of the story. They investigated how cycles compete for dominance and how different needs collide. The main elements from the story have been identified, the arrows demonstrating cause and effect due to the change in the elements. As more needs are produced, there are more profits, which means a bigger factory is necessary. Size and greed equal more trees cut, which affects the environment, the animal population, and the Lorax anger. Here you can see the students separated the systems. The trees make the needs, business makes money, and pollution hurts the animals, which the Lorax protects. When you interrelate the loops, you can see that the more needs that are made, the more trees that are cut down, and the more money that is made, which causes the desire for more money, which means more needs need to be made and more trees need to be cut down. Through these examples, we now have a better understanding of the systems thinking approach. These principles are essential to transforming our thought processes. In fact, it is the foundation of leading for change.